Hello and welcome back to the development of the Feersum Scheme compiler. So in this stream I'm going to continue the work on implementing scheme libraries, and let's start by going over, as usual, what went on in the last stream. So we were looking at the parsing of libraries. We added this new libraries module to the compiler, which has got a bunch of different functions for parsing a library definition. So a library definition looks a bit like this thing here. So you have a defined library, you have the name, and then you have a list of declarations. We currently support parsing exports, imports, and begins. And our parser basically uses the parse library declaration, which looks at the kind on each one of the forms and works out whether or not it's something that it supports. And that's it, basically. We were initially doing all of this parsing in the binder, separated it out into the libraries module so that we can separate recognizing a library declaration from actually binding it, where we resolve the names and work out what all the different bits of the library are actually supposed to mean. So that is the focus of today's stream. I would like to, at the end of the stream, be able to compile this piece of sample code. So I'm going to start off by just copying it, and we will add a new spec and see where we're up to. So calling it libgreet, pasting it in. So I'll just make it a little bit bigger. Our library here is called test greeter. We export the single item greet. We import scheme base, and we have the body of the library, which defines a top level item called greet, which is a lambda that takes a single argument and calls display a few times. So we should end up with hello space, the thing that you pass in, an exclamation mark, and a new line. And then we import from test greeter only greet. So this is a new form we'll need to support, which is an import declaration, which would look in the current scope for a library called test greeter and import these declarations from it. I think I've got that right. I haven't actually checked that yet. And then greet, we actually call the thing that we've imported. So let's have a look over what the scheme language spec actually says about this whole thing. Program structure. Libraries. I just can't see it. So yeah, we're not supporting any of the include ones yet. It talks about how when a library is loaded, its expressions are executed in textual order. It's done transitively, so if you load a library, any library that references, blah, blah, blah. I believe there's also a rule that says that, regardless of the number of times the library is loaded, each program imports its bindings, must do so. Basically, every time you load a library, you load whatever the cache copy of that library is. You don't re-execute the blocks each time. So the plan to solve this will be to use static constructors on a type. So all of the declarations for a library will be bound into a new type, and then the first person to reference that type will cause the library to get loaded. Or we could have it so that every time we encounter a defined library, we emit some kind of ensure loaded call. I'll have to think about that. But for the time being, the thing that matters is importing and exporting. And how we bind the body. So this is what I was looking for. One possible implementation of libraries is as follows. After conda expand, we don't support that yet, library declarations are expanded in a new environment constructed for the library consisting of all the imported bindings. Begin, include, and include CI library declarations are expanded in that environment in the order in which they occur to the library. So this is the structure that we will use to expand out and actually bind our library. Effectively, when we get to a defined library, we'll parse the whole thing. We'll create a new scope for the library, run through all of the imports to add them into the scope, and then bind all the bodies in the order that we see them, and then put all of the exports into the outer scope or into a library declaration. So the way that we currently let's have a look at actually running this example first. It is that? Nope. What is the terminal command on Linux? Every time I crack open my Linux laptop, because I use Mac OS at work, it takes me a while to get used to the key bindings, and then I'll get to a stage where I'm used to it, and then I'll go back and I'll have exactly the opposite problem, getting all of the keys wrong on Mac OS. So if we run our compiler, we can do that with .NET run. So it is in Feersum. We can pass in spec libgreet, and we will output it to spec bin so that everyone's happy. .NET run. Got to compile a compiler, then compile this libgreet program. So I'm expecting, yeah. We parse it fine, and our binder is upset because it starts being upset here at line 11. It's nice that you can click on these. Our diagnostics are actually mildly useful. It starts here on line 11, column 2. It's upset about the import, and then it says on line 10, it's upset about test, and then greeter, and then it's only, and then greet again. So basically, all of these symbols it thinks are supposed to exist, and it can't find the definitions of them. And it's not wrong. So this is all about supporting top-level imports. Let's have a look at how our library actually gets bound at the moment then, and work out what we want to do about it. So Feersum, what's the options on this? Okay, right, so I want the compile one, and let's also go to the binder and put some breakpoints in first. So we've got a bind library declaration here in our binder. So let's see what happens when we run it. So we want to do spec lib greet. So it's building. I've not used this for a while. Very impressed if it just seamlessly works. It does. So we've got a library. Our library has some declarations and a name. So the name is a list of string, test greeter, and the declarations should be export, import, and begin. So yes, we've got the export of greet. We've got the import of scheme base. Our current binder is going to make so it does try and bind the bodies. What is this doing? It says fold back. So well, first of all, that's the wrong order. It's doing, if it was a begin, I say it's because it's building up the list. I think this might end up being in the wrong order. So this is building up the list from the back by just pasting things onto the front. If they are begin blocks, it's binding it in the library context. The problem might end up being that the library context ends up like not being mutated in the right order, but for the time being we can just deal with there being a single begin block and we'll all be good, I think. So this will end up binding the body okay, I think. So we should end up with a bound body here, which is a bound expression, and it's doing store global, a lambda, which takes the person, blah, blah, blah. So that's actually done the binding correctly for the body of the function and the whole body of the library. The thing that we're not doing yet is adding declarations for the library anywhere. So we need to support lowering of the library. So that, I guess, would be in the emit, we'd need to support the bound expression library and actually emit the code for a library when we do that. And we need to support storing the library somewhere. So let's have a look. What we care about are the imports and the exports. Stream dropped for some reason. I was just talking about import declarations. And renames. So we have a library, we have a list of exports. We want to build up a list containing all of the names that the library is going to export. Do not know what is going on with my internet connection at the moment. Oh, seems to be okay. Twitch says it's unstable. Shout out in the chat if you can't follow. So we're going through the library already. We could, according to the spec, we could just go through and process each declaration bit by bit. Is that what we want to do? Yeah, I mean, I would like to. Well, I guess we can make one pass through and build up the library. We can build up the library names and Yeah, let's try doing that. Now let's do this. Let exports equals no exports. Then we do list dot fold. Map fold. It takes a mapping state and a list of things and produces a list of results and a state. So that allows you to modify something. Filter. Map 2. So map 2 takes pairs. Map 3 takes triples. Map with index. It's none of those. It's a way of shuffling things. Pick. That's the one that returns. Scan's the one where it gives you the state each time. Try. Unfold is a way of producing a list of things from something. Choose. Okay. Is this what we want? We give it a chooser. That looks like what we want. Yes. So let's first off, let's get the previous thing, which is effectively a choose. So list dot choose takes a body, matches the body. If it is a begin, it binds it and returns some. So we'll just get rid of that bit like that. Get rid of that. And then here we return none. That looks nicer. And I think that should be able to be unindented now. So that's basically going to scoot through the list and produce another list for all of the things. I'm so glad I found that function. I was looking for it for ages. I knew it had to be there somewhere. And then we want to do the same thing with exports. So let exports equals list.choose. And we'll do body. Can I make this a function? I can. Function. And what are you upset about? Oh, incomplete pattern matching. Well, that's fine. Libraries dot declaration dot. If it is an export, we'll process it. Otherwise, return none. So this export should now be a list of an export, a list of lists of export set. Is that because? Do we have a choose many? Maybe we need to combine it. That's a cat. So we can just do like a list dots concat, I think it is, which takes a sequence of lists and returns a list. This one wants to be given the list in the first place. This is library.declarations. So I think what we probably wanted to do was this. Library declarations, piped it to the choose. Can I get away without the braces there. No, it doesn't look like it. So we've got the export sets. So the export sets are let's map them. We want to do list.map, I think. And we'll do this in one big pipeline chain. So we'll do export pipes to list.map. That's going to be libraries dot. Maybe I should just import. If it's plain, I'll just return it. Otherwise, error. No, not error. Renamed. From 2, we'll just return the 2. And anything else. Fail for the time being. So that's going to produce a thing. We can then pipe that into the sum. So this should be a string. That's also a string, hopefully. There's a red squiggly down here. Yeah. In the binding of what? Oh, I see. So that wants to be there, and then that could be a thing. Is that right? Is that what you're complaining about? I mean, how is this? How is what I'm doing here, which doesn't seem to work? Because I think the problem is that it thinks that this is still part of this. Different from here. It's better if I get rid of that. I use the identity function instead. So that's a list. So that's an option of lists of export sets. Then we can do match X with, paste in all the other things. So now it says it's a list of object. Is that it? Expected renamed. Expected to have symbol rename. Okay. So if it's a rename, what do you want to do? R dot. What is a rename? String. Dot. Why is that not working then? Yes, because that needs to be symbol rename. That's awkward. Spell libraries. Probably not. It's our list of strings, and that's a list of options. So now let's see if it compiles. Excellent. Where do we ever use that export set error? Can I just get rid of it? It's going to be awkward, isn't it? So it's there where it's defined. Parse export declaration. Can parse export declaration be fallible? Could, because we could make it a library declaration error instead. So let's do that. Let's, in the binder, get rid of the error. And then when we parse things, we can't do export set error, so we'll have to do results.error here, which is Yep. It's a string. It's only emitting the diagnostic. Make this one easier. This can just be results dot error, and then the string that we gave it earlier. This can be result dot error e, which is effectively the same thing. What are you upset about? Ah, yes. So that needs to be okay. Export set renamed. And this needs to be okay. Export set plain. And now what are you upset about? Okay, so we need to find the places that call this, which should be here. So now we're going to get, instead of an export set list, we can do that's because it's inside a list. We could, now we know about list.choose. Yeah, I do know that I don't need to reconstruct the error. I was just leaving the smallest code change in case I needed to back it out. If we do a choose and then an export, we can make the parse declaration return some or none instead. Let's see what we end up with this. No, that must be some. Kind of feels a bit wrong, but and then down here we can do an emit. Export location. Problem with that was that it kind of feels like we're doing something similar in this error case and in this error case, and it would have been nice to have returned an error instead and have the thing that was calling parse export declaration register it. But I think this should compile. And now we're going from result into option, and we can't really do that. Just the as pattern. I mean, what I would have done with that would be you could have done rename. Let's just write the whole thing back out again. What you'd be able to have done, you'd be able to do rename, try parse rename, because it's probably worth following through on this because it might end up being something we want. And then we could do result.map. map the export set renamed to wrap it in a renamed. And then we get a result of export cell string. Let's follow that through. And this would be okay. And then this would be result.error. Why is that export set option? I think you're just a bit confused. It's because the call site is affecting the inferred type here. So we would do list.map, and then we get I'm all right. Distro is Fedora. I was on Manjaro last year, but I tried to boot my laptop one day and it just wouldn't, because I'd left it for too long and then everything was in a bad state. And one of my colleagues at work is a huge Fedora fanboy, so Arch Linux do be like. I mean, it was nice. I did enjoy it, but Fedora only breaks some of the time. I did actually spend about an hour before this stream trying to get v4 LT loopback to work, and ended up having to uninstall and reinstall the NVIDIA drivers because for some reason the CUDA support wasn't working. So no accelerated video encoding, which is wonderful. But yeah, those kind of things seem to be slightly less frequent on Fedora. So if we do map error, they've lost the location then. Yeah, let's back this back out. It's not the best that we don't I was changing the wrong thing even. If we do list.choose here, and then in this declaration we do some this can be diags.emit export.location. Do that as a none, and then what do we do here? So we got we now got a list. No, yeah. So this rename is now a result of export set or string. To be honest, I think the original match expression might actually been the easier way to do this. Like in terms of the most grokkable way. Maybe try parse rename with, and then do if it was okay. Return some export set renamed. If we got an error, then emit and return none. At least it compiles. This rule will never be matched. Fair enough. That is the thing we were trying to get rid of in the first place, so it's good that it won't be matched. And this can be a function. I was just messing up somewhere else. Then what's this saying? Rule will never be matched. Yeah, I think that's just the error at the wrong position. Because for a start, it's pointing into the right-hand side, not the pattern. Yeah. So we have a list of exports, which is a list of strings, but we kind of don't want it to be a string because what we've done here with a symbol name rename. Do we care about it being so? I think these need to be pairs where the left-hand side, or the first item in the pair, is going to be the name that people can use to import it. And the right-hand side is going to be a storage location so that we know where to read it from. So we'll call these globals. So a global at the moment just takes a string. We'll just use the string. And then this is going to be from and into. So from. So we'll say into. So into is the thing that's being renamed into. So that'll be the key. And then we can do storage ref global from. that means if you try and look it up by the renamed value, the thing I'm just thinking of is that I think these are supposed to be a bit more recursive than this. Like, I think the... Or maybe you can only do... Let's have a look. What does the spec say? Because can you just like infinitely rename things on export? I know they are. It's an identifier and identifier. I thought that maybe this was actually like an export declaration or export spec. So if it is just either an identifier or a simple rename, that will work. We've got a list of pairs. Concat them all together. I'm thinking where I'm going with this is that we might want to... Well, I guess what we want to do is build up a scope out of them. Maybe. And then we can store that somewhere. Scope from map. What does that take? Let's see if we can do from seek. Because if we can do that, I have a feeling it's going to be pretty... It's going to do map.fold. Okay. How many people call this? Not many places. We'll leave it around. It's not really harming anything yet. Insert takes a scope, an ID, and a value. Hello. My water is being stolen. Not that code. Let's get rid of this and just say, yeah, you have to give us a map. And then in libraries, in the binder, so it's binder, wasn't it, that we were doing in here, we can do list of map of list. And then scope from map. Probably not really the most optimal, but so we have a scope. And then I think what we want to do is add that as a library somewhere. Does it? Given the way that people are going to use these, does it really need to be anything more than a list of pairs? Probably not. Anything else is probably going over the top. So let's context, add library. Name exports. And then we need a way of storing these things. So in the binder context, so we have the scope, which is our current one, outer scopes, which is where we're gonna, I don't know, what is outer scopes? When we add a binding, we check outer scopes. If we're at the root level, we add a global. Fair enough. Oh, okay. So we push onto that stack every time we enter and leave a scope. Fair enough. We're probably going to want just libraries, I guess. What is it gonna be? We've got the trouble here is let's give you a list of something. So I think it's going to be a list of string list string storage ref list lists, if I spelled string correctly. Now that doesn't look great. I think this should be like a library signature or something. Make it an actual type. Yeah, go on, let's do that. What's all this red about? Yes, so libraries would then need to be an empty list. When we create these bind context, we probably want the ability to add like library declarations. So we'll have some way of doing that as well. Because at the moment we just have our built-ins that we just always look for in a specific library. But ideally you'd be able to specify where the standard library is. And we would scout through that for library exports rather than what we're doing at the moment. Down here, add library is going to need to push onto that list. Try find binding. Add binding. Name, export, I guess. Context libraries is, we'll add a new name, exports onto the beginning. So this means that library declarations are effectively global within a binder context. I think that's how they're supposed to work, but we'll see. I think in theory you're supposed to only be able to define them at the top level as well, so maybe we'll have to add a warning about that if you try and define a library inside a library. Is that because you don't know what type it is? Is that because I've spelled add library wrong? Or do I need to do binder context? I think I might need to do it this way, don't I? I can never remember. There we go. It compiles and everything. So let's run again and see what we end up with. Have I still got my breakpoint? I have still got my breakpoint. Spec lib greet scm. So create a new context. We bind all the bodies, which works, which is good. Then we collect the export declarations, which is greet as the global greet. We still need to put the library name into the global declaration. So we're probably going to need a way of mangling it so we get like a C# name for things. Then we add the library and return the bound expression. Good. What does the terminal say? We still get all of these things. But the key thing now is that we could, in theory, allow you to import things. So let's stage what we've got at the moment. Let's not stage libgreet. And what have we done here? Let's have a look through what we have implemented. We have this list of libraries, and we put all of the exports from a library onto the binder context. And we've got rid of the error type in export declarations. Well, we can actually do that as two separate things. Make export then in the binder we say store export each exported item each exported item is collected and stored on the binder context. That's all we really need to say. So now what we can do is support imports. So let's do the top level import first, because that's the one that we care about for the greeter. And then we can refactor it and hopefully use most of the same stuff for the library level ones. Let's just edit how to do global import. Yeah. Whoop. It's not going very well at all. Ah, it's because this is Emacs. Library export. So we've done library exports, including renames. So do we already have a definition for the imports? I don't think we do. Yes, library should still be seeded based. That's still not been done. So let's add another form. I'm just going to steal cons because why not? Import. And we have a parser for this, so we can do libraries or let import. Ooh, do we have a parser for it that is public? No, but we can make it public. So we have parse import declaration. So just like we had parse export, returning an error. I feel like maybe we should do the same thing here. Let's try. There's an awful lot of cases that end up in an error here. But we're already producing diagnostics, which is positive. Parse library name. Parse library name. Yeah. This should produce. This should produce a result, shouldn't it? So let's keep the existing signature. The stream drop. Yes. So all of digs add okay, so we have our parse import declaration backwards compatible, and then we have the try parse. So try parse, we just need to get rid of any. Can that be try? We'll see. Result error. We just passed that back rather than as an import set error. Let's see how far we can get with this. So we've got the result. So it's going to do parser on the body. Result collector. Try. I can't quite, some kind of higher order fold thing going on there. But I think we can do parser body to run the parser and then pipe it through result.map like that. And then we end up with the diagnostic. Oh, that would be result collector like this. Just that as a parameter, and then we get into the interesting part. We're not building up a list of diagnostics. Do we just give up and back it all out? I think so. Discard. Discard. So. Overwrite. What have we got staged? We have an import, and that's it. Good. Tea's gone cold. We wanted parse import. I think it wants a diagnostics list to a diagnostics bag to append it to. So that's going to be context.diagnostics and a body. And this wants to be a bound no op if we have one. We don't. There's no reason why we. Do we have anything that expands to undefined in the emit? Oh, no, that's not what I wanted. Compile, that's what it's called. Emit unspecified. Let's just make a bound no op. Probably come in handy for other things. Not, there's nothing. So down here we can use not. We need to work on adding a libraries. Let's just clear down some of these things. I've got stuff staged in here. I have. Let's discard that. And DAGs body. Parse import form. Parse import declaration. Okay, so this parse import declaration is getting used. Like this. So I think we're going to have to do body pipes to parse import declaration. This. Then we'll end up with a list of imports set. You sure? Pretty certain it's there now. Let's see what we end up with here. I'm also not entirely sure that we do actually want a no-op here, because we were reading the spec earlier and it was saying that libraries have to be initialized. I think this might actually be the point where we need to initialize the library. So we'd call some function on the type for the on the library type. Libraries dot parse import. I just spelt it wrong. It's building. Let's try running it. So spec lib greet scheme. We can skip over that for the time being. We trust that. Now we've got import. So the import has, let's see, can we parse it? So we've got two things. Ah. Yeah, so a raid. Grumpy Game Dev. Ah, I've seen you streaming a few times. So, what have you been up to? I'm deep in the middle of adding support for Scheme libraries to my Scheme compiler. F sharp. Yep. I mean, I'm not the world's greatest F sharp developer. I've only learnt what I need to for this, but I do enjoy it as a language, and I found that I'm able to drop in and out of F sharp a lot more easily now than maybe even just a few months ago. It's been quite easy to pick up, and I think some of that has to do with the fact that I've experience with C sharp, and so I know a lot of how I would expect .NET to work and how to use the toolchain and things. And then also languages like Rust, which really left me thinking in a kind of functional way. But I don't know of many games that are written in F sharp. Hopefully this will be interesting to anyone who's joined anyway. So what we're trying to do at the moment is what am I missing out on? I don't know what that is, but I'm sure it's great. One of the kind in a kind of you'll regret it, or oh yes, games are nothing but state. In some ways, so are compilers, but in some ways, F sharp's good because building up trees that you then just walk over and turn into other trees, that's the stuff that F sharp's great at. But then sometimes you do actually need to have like a mutable thing that you're adding references to. And I think it's that almost any non-trivial program will have some kind of mutable state. But most of this code does not use mutables, which is good. The other thing that makes it quite a good language for writing a scheme compiler is that with both of them being kind of functional languages, you don't have to change mindset from thinking about the code that you're compiling to thinking about how the compiler itself should work. So our import statement was broken, so we've ended up with an error. Fair enough, really. So I think, let's go have a look at the spec. We have import. Where does it actually specify section? Is it this one? Yeah, I think it's this one. Yes. We might be passing the only declaration wrong. Let's just get rid of the only for the time being. So an import is not An import is a list of import sets. Oh, okay. So if you want to do only, we'd have to do. Oh, well, that's gone badly wrong. If we want to do only, we would have to write it as import only test greeter greet. Let's do that then. Just for the lulz. Now let's see. Spec lib. What we end up with in the binder. Hopefully that import should then be just a single item. It is. And it says only, and then a plain test greeter greet. So if we want to handle this, how do we... Basically, we want to loop through these imports and add the bindings. So let's just do that. Let's say take the imports and do a list dot. Let's just do iter. And then we'll have like add import context. And then it needs to take an import as well. How do we deal with other declarations? Declaration binder. Where's bindlet get called from? Does F# have type aliasing? You mean like C's stuff where you can say F# is kind of picky about types, even to the point where it won't allow coercions implicitly, which is usually a good thing. Where types become odd would be like you can have a type. If I did like a type foo, which was like a string int pair, then I could create something. Let's do create a function like this, and I could say that the function returns a foo, and I could return that. And this is kind of like implicitly converting a pair into the type foo. But the way around that is that you can make foo a single element discriminated union like that. And then you can't just implicitly convert. You'd have to do foo. But depending on what you want, that's about the only time where types get a bit coerced. So I think we want to do binder context, add binding. So what was the import we passed in down here? The parse, each one of these is going to be an import set. Let's do add imports from set then. Nope, not that one. This one? Yeah. So let's go to context, and this will be the import set. So let's just be clear about that. And then we do binder context. No, that's not a type. I haven't opened libraries for reasons. Add binding to the context. Okay, so that's expecting to take a string and add it into the current scope. Do we have a way of just saying I already have a declaration? I mean, we could just delve into the scope. Or we could make this part of the binder context. Add imports from set context. That kind of makes sense. That you'd ask the binder context to update itself rather than just delving straight in. And then what would we do? Add all the bindings from a given so we do match, I guess. I guess there's two parts to this. The first thing is we need to look up the library and find out what the exports are. And then we need to go through those and add them into the current scope. You're thinking about mutable and a way to shorten it with an alias like type. Yeah, so I don't think that would be valid code to say type foo equals a mutable string, for example, because that's not going to be there. But what you could do is you could type foo is could you do foo of? That doesn't sound like it's going to work. But what you could do is make it a struct and just do. And then like have all of your associated functions on there that do the mutation. Or as we are doing down here with the binder context, we have a module binder context and a type binder context, and the module has a bunch of functions for mutating or just generally dealing with things. So what are we doing here? Let's I guess we want to say exports equals find bindings might even want to make this private. Which for the time being can return an empty list. And then we take the exports and map them. The compiler is for the Scheme programming language. R7RS, which is the revised Scheme spec. Yeah, I understood that what you were saying with pseudocode. The thing, I think, often the most difficult part about learning a new language is if you already know existing languages, you can be tempted to think like, how can I do X? Where X is something that you can already do and you already know how to do. Whereas the new language might have a different way of thinking about things or a whole different set of tools that you'd be missing. So we've got our bindings. If we pretend that's capable of looking up all of the bindings, in fact, let's just say context dot libraries. Just gonna take the first one and just say that you always manage to import everything from there. One thing I do miss in Rust is if you've got a tuple, you can index into it. So we're getting a list of strings storage ref, in which case string is the local name it wants to be bound to. So we take all of the exports and we do I'm going to push it into the scope. I mean, fun. What is this going to take? It's going to take the name storage. And then mutate the scope. Oh, it must be ID. And we can clean this up a little bit by just piping find binding straight to list editor. Since we only have one library, let's see what that does. So if we see any valid import set, we'll just always immediately import everything from the first library we find. So that's going to be spec lib greet. Let's go and have a look at libgreet while we wait for the compiler to compile. So hopefully we get down to here, we do the bind for the import. Because this is a valid thing that you could theoretically import, we'll just blindly take the first library we find. Let's get rid of this breakpoint because we don't need that anymore. So in here, we'll call find bindings, and then we should now have greet in our scope. There's a lot of stuff in here. So we've got global greet. There you go. And now that means that when we go on to bind the rest, we should end up with no. I didn't listen to the problem. Incomplete pattern matching. Not. We need to admit unspecified. I think we just need the context. That's it. Yep. Hopefully that works. I've started learning Haskell myself a few times and then never really got very far. I don't have anything against the language. It seems quite easy. I've just never really had anything decent to do with it, which is always my problem when trying to learn things. Let's just let that run and see what we ended up with. No errors, which is good. But yeah, the switch from C and those other kind of imperative languages to thinking functionally is a big thing. And once you got it, though, I think it generally just sticks with you, even to the point where often you'll find yourself in an imperative language thinking like, oh, I could do this with functions and like modeling things. Because there's I don't know who came up with it, but I expect it's going to be like Dijkstra or someone like that. The functional object equivalents with like things that you can model with functions and closures. You can also model with objects. They're really just two different ways of thinking about the same thing, but frames of reference really matter to humans, at least. So some people find it easier to think as functions and data flowing through, and some people find it easier to think of objects. So with any luck, in the spec bin folder, there should be a libgreet. Right, so think we just need to run the tests, get them to compile it. I think it's been compiled as a... So our compiler supports compiling as executables, libraries, and scripts. I think the libgreet has been compiled as a script, and so we can't use it directly. We can compile it ourselves. Okay, we should be able to do .NET spec bin libgreet. There's far more stuff there now, which is promising. Core dump. Object reference not set to an instance of an object. Great. Maybe a little bit premature on the celebration here. IL-spy command. Show me the IL. So what we're looking at here is the .NET intermediate language for the output of our compiler. And we just, when we ran it, we got a null reference exception from inside script body, which is the kind of static root thing. So what's it going to do? It does a few things that result in an undefined. So I think that is defining the library and then importing the library. And then this is the call to greet. So it is doing load static field libgreet list program. I can see the problem straight away. We never actually bothered to compile the body of the library. So we just have a stub that's trying to call and nothing for it to actually call into. So we need to, in the compiler, I bet we've got a to-do somewhere for library. Emit library. Yeah, lower the body of library. So what is the body? The body is a list of bound expressions. So emit sequence. This might do. This is probably not the right thing because we're going to be emitting into the same type. Yeah. So let's do body. Type to emit sequence context false. So we won't do any tail calls. And then that, I think, should work. Yeah, and then that will fall back to emit unspecified. So we'll always end up with something emitted. IL-spy is very useful when you're emitting .NET IL yourself. I've never used it on anyone else's compiler output, but yeah, it's very useful. The only thing I had a problem with was sequence points when trying to emit debug instructions and stuff. But the code base is actually open source, and I had to dig around and made some changes. So you can now, if I had to compile this in debug mode, you would be able to do ILSpy and see the sequence points from the embedded PDB. Let's see if this works. Where were we? This one? That doesn't look quite right. Yeah, this one with all the ILSpy. So we want to do that to compile it. Hopefully the compiler doesn't segfault. So first this has got to run .NET to compile our compiler, run our compiler. Oh dear. Attempt to lower an error expression. That's not great. Well, I guess we are back into the debugger then. Yeah. So that's fine. But then, yeah, this. But where are we? That didn't really seem to take me to anywhere interesting. Ah, emit application of error. The arguments are hello. Okay. Submitting an application. What's the expression? Error, literal. Let's go all the way up. Oh. Display is not there. Because we aren't processing the imports on the define library. It's supposed to start out with an empty scope. But there's two problems here. One is the fact that we're not importing display, so we can't call it. And the other one is the fact that the compiler got far enough through that it tried to emit the code for the bad tree. So something must have gone wrong when we bound the body. We didn't properly deal with any errors that it produced. So where would that be? Down here? No. Find library. So bound bodies. Ah. Yes. So let's show why I've just come to. Okay, so lib spec lib greet. So bound bodies, exports, and now if you have a look at the library context, so this is the inner binder context that was used to bind the body of the library. We have all of this information, but we also have diagnostics. So what we need to do here is add the library and then also do context.diagnostics dot append lib context diagnostics. I think that's all we need to do. What does this take? Just takes a sequence of diagnostics. Oh, we want to take. So take the diagnostics out of the inner context and put them in the outer one. Context stores a reference to the library now. So now if we run this from the terminal, the other terminal, we should end up with an error telling us that greet is not defined. Thinking of writing a to-do app in F#. It can definitely be to done. I don't think it would be. You're talking about a web app or something you can use from the command line. I always see lots of those command line to-do apps, and nothing ever gets better than just putting a list of things in a text file for me. So yes, display and new line are undefined. I think we might be able to fudge this. So where do we create? So we have the empty. We also have scope. So if we did bind create root scope. This would be a super hacky thing. I could do create root scope, but I'd need to move it. I think. Just to remind myself that this is a massive hack, what I'm going to do is just copy and paste the whole thing rather than moving the body. And call it hacks. now at least our compiler should be able to compile that piece of code until we can get imports working. Yeah, can't you just do .NET New whatever you want? So like .NET New Unicorn, get the investor dollar. Now we have a thing. And yeah, I was expecting an exclamation mark, but I don't really know why. It's a character, isn't it? Not a string. So it's being printed out because it is display, and my display just prints out the round trippable representation of it, or the human readable one. If it isn't a string, if it's a string, it prints out without the quotes. So that's where you're ending with the exclamation mark. But this kind of almost works. We just need to support imports into the library scope. To be able to import scheme base, we're going to have to support being able to store scheme base somewhere. This is feeling like maybe this is a point to wrap things up and commit. So we have the NOP. We have more NOP. That probably wants fix me here. Library bodies should still, we'll stage that as is. Got parse import. Yeah, that was, no, I'm happy with that. That kind of works. And then we've got this, and let's try running the tests because I think this is gonna, there's gonna be a few things that'll fail because we haven't yet updated the snapshots with the libgreet. Okay, close some of these terminals. Yeah, we have 2 errors. Snapshot missing, yes. And snapshot missing, so let us update the snapshots. If this all passes, then we can commit. And the cat wants to go outside. Oh, thanks for the follows, by the way. I've not been keeping track of that. Looks like Master and Surly. Tests passed. That's the output for the time being. Got that initial hacky import. Global import support. Still to do. Library bodies God, let's have them all as lists. Libraries need to be able to import other libraries, and then the last thing is that we need to have some way of making scheme base importable. Make core libraries portable. So that's going to be a bit awkward because the way that currently works is bind down here gets given a scope. So bind is called from compile. So compile calls create root scope and then calls bind on it. It doesn't really need this scope. So we could make the root scope again, we could make so that we could hide it in there. The other thing is that we probably want a way to pass into bind a list of libraries that you're referencing. So like when you compile for .NET, you've got all of the NuGet package, you download all of the assemblies in there are things that you can reference. We'd like to be able to say, please bind, but also reference these libraries. And the way that create root scope works at the moment is that we have this built-ins that is looking at specific, well, it's got built-in macros, but it's also doing find built-in methods, which looks on a specific assembly. The assembly that we pass in is this type of blah. So it'd be nice if when you call bind, you passed in the core assembly and all the others, and we went through and found all of the library declarations in there, which would mean that in the core assembly, we have all of these, brace yourself for some C#, we have all of these types, so like cons pair, and we also have methods. So here's the ones for byte vectors. We'd need a way of marking up on these classes that this, like this is the library for scheme base or whatever, so that these exports get added to the scheme base library. Not 100% sure. You could probably do it once per type and then have it. But yeah, there's got to be some kind of like, once we have those globals, we can store that in the binder context. So when you call bind, we will have like all of the libraries already. So when it calls create for global scope, you'd pass in like the libraries as well. We'd discover all of those. We'd have discovered all of the signatures, and then probably we'd make this thing here. So inside our binder context, we now have this list of pairs of string list, which is the library name, and pairs of storage refs. And we'd probably want a type for that, and we'd want a way of the built-ins producing those from assemblies. And then you'd have it that you'd pass in, like, you'd probably have some kind of metadata reference kind of thing. We'd have implicit ones, all the rest of that. So that's the kind of direction that I would like to go in the next stream, but for now, that's it. So thanks for watching. Thanks for the follows, and I will see you next time.